I am Dweedoff. This is A. Especially for this first lesson, I will ask that you don't spend a ton of time working ahead because there are some finicky details I want to make sure we're cool with. You might be fine with them, but I want to make extra sure you are fine. And the danger with working ahead is that you don't go back and fix the issues. Okay, so exponents. You would be introduced to these exponents and powers last year or the year before, grade 7, grade 8, some point in middle school. You should definitely have seen these before. What is the point of exponents? Hello? Hello? Okay, that was quick. Okay, thank you. Okay, bye. Okay, so we talked about this before when we talked about simple, like adding, subtracting, multiplying, and dividing. The point of multiplication was to represent repeated addition. What is the point of exponents, Guntas? I saw your hand. To multiply a number by what? By itself. So repeated multiplication. Cool. And so we've got language for this. This whole thing here is called a power. And it's made up of two parts. The 2 is called the base. The 2 is the base, which makes the 3 the exponent. And the base is the number that gets repeatedly multiplied. And the exponent tells you how many times the base is multiplied. So, if I have, in the way you'd say this, 2 to the power of 3 or 2 cubed, if I want to write that as in another form, I could represent that as repeated multiplication. So 2 cubed could be written as 2 times 2 times 2. We're going to do right here. 2 times 2 times 2, which is 8. So this form right here is called repeated multiplication. And this guy right here, the 8, is standard or evaluated form. There are names for all of these forms. Power form, repeated multiplication, and then standard or evaluated. Actually do the math. So the exponent represents how many times the base is repeatedly multiplied. There's some equal signs that I forgot to take out of here that definitely need to be here. 2 cubed is 2 times 2 times 2. 5 squared is 5 times 5. Let's go the other way. If I told you it was 3 times 3 times 3 times 3, how would we condense that? How many 3s are there? 3 to the 4. 3 to the 4 or 3 to the power of 4. And then this guy would be 7 to the 3 or 7 cubed. Good. You guys get calculators this chapter. Some of you feel quite good about this, I'm sure. Get your calculators out. I want to make sure that you're all comfortable with the calculators that you have. If you do not have a calculator, you may come borrow one from me. You put your phone in the slot, and then you come and grab a calculator. I'm going to grab a few out of here to demonstrate for you how they work. So get your calculator out, or come borrow one from me. Here you go. Come get a calculator, or get your calculator out. Okay. Okay. Okay, so there's a set of instructions here. Not all calculators work exactly this way, but largely. Every calculator works a little different. You need to know how yours works. If you have a 2-line display calculator, it should work the way I am going to demonstrate on my 3 calculators here. I have 4 different kinds, but there's really only 3 major differences. The Staples calculator works exactly the same way as the TI. So if you're sitting there borrowing a Staples calculator from me, did anyone grab the Staples calculator? It says Staples up at the top. Okay, Fariel did. Okay. It works the same way this one does. So I'll show you what else looks like. The Sharp. Let's do the Sharp first. So if I wanted to do something, I don't know what I did last class, something like 2 to the 7. You push the 2. This calculator, you use the Y to the X button. It's that guy right there. I'll zoom in a little bit here so you can see a little bit better. This is the do all of the different exponents button on the Sharp calculator. It has a squared button, it's got a cubed button, but this one will do it all. So I want to push that. I'll slide this up here so you can see the whole screen. And what it does is, I don't know why it does this, but it actually uses this up arrow notation, which is the same button symbol on the TI. So I don't know why it wouldn't just use that same symbol, but whatever. That's what it does, the Sharp calculator. I don't love them, but I have them as examples because so many students buy them even though they're crap. If you can avoid using the Sharp calculators, avoid using the Sharp calculators. So 2, and then the Y to the X button, and then the 7, it equals, and you're going to get 2 to the 7 is 128. On these calculators down here, it's similar. I'll do the TI next. If I turn it on first. 2 is 2, and then you push this is the to the power of button. And then we push 7. It looks exactly the same as the Sharp calculators, except it types up here instead of down here, and then it gives you your answer, 128, and that result sure as heck better be the same. Close that, and then this is my favorite calculator, the Casio's. We want 2, and then the power of button, I gotta turn it on first, 2, and then the power of button on this one is a little bit different. On the Casio's, it's actually this guy here, X, and then it's got the raised box. That is X to the power of box. So we're going to push this, and now it opens the little box, and you can start typing inside. I could push 7. You could push 7 plus 3 times 6 plus 8 minus... And this whole expression will show up in the exponent. So you got to be careful when you're using the Casio's, that if all you want is 2 to the 7, you put that up there, and then you actually have to push this arrow here to get out of the exponent if you want to keep typing other things. U equals, and then obviously it's going to give you give you the exact same result. If you are working with a single line display calculator, your calculators are going to be different. It may or may not behave the way it is supposed to behave. Yes, Carson. Now is not a great time. Like middle of the lesson is not a great time to go to the washroom. Guntas, what kind of calculator you got there, man? One line, what's the brand name? Yeah, you need to get a better calculator, man. You need to get a better calculator. Have you figured out how to do this on your calculator? Okay. So do you see a arrow button? Have you looked? Are you looking at your calculator? Do you see a Y to the X button? Are either of those buttons there? Okay, so you're going to push 2. You're going to push the Y to the X button. The only thing is you're not going to see this. You got to remember what buttons you've pushed and hope you push the right ones. Which, I'm not saying you have a bad memory, but my overall understanding of the state of my grade 9 phone addicts is that you guys don't have a great memory. So the 2-line display calculator will display what you've done. Guntas, get a better calculator. You can do it for like $12. If you don't have $12, go mug someone outside a gas station. You can get $12. Don't actually do that. You'll get arrested. $12 is not hard to get. Collect some bottles. Deposit them in the depot. You'll get your $12 and you go get another calculator. But then you'll push your 7 and you'll hit equals. The only thing, Guntas, you won't see is all of this work happening in the background. I'll demonstrate something here in a second where your calculators will probably go a little bit squirrely and why I don't like Sharp or 1-line display calculators. Okay, so crank out these 4 here at the bottom. Make sure you're cool with how your calculators work. On your mark, it's a go. I think over the lifetime of our student, I've gotten 400 or 500 bucks back. Maybe gap. And the laptop was a big one. Yeah, there you go. That's not a question. Don't use the square button. Show me that button. All the instructions, yeah. Do the X button. Yeah, don't use it. I want you to use the other button. Sorry. Yes, you did. You typed it wrong. That's why I wanted you to do this together. You can give it in another one. Please point it in. Yeah. Except these are the ones I want you to do. 5 and 4 is not 20. It's 5 times 5 times 5 times 5 is not 20. Touch it in your calculator. I want you to use your calculator to do these. Exponent means repeatedly multiplying. Hello, my son. How are you? Hey, buddy. Come on. Oh! My son. Thank you kindly. Appreciate it. Have yourself a good night. Okay, Jack, bye. Bye, buddy. You have a good day. You be kind to mommy. Nice. Okay, you should have these 4 done already. What are they? 5 to the 4 is? 625. What is 4 cubed? 64. What is the next one? 13 to the 1 is 13. And 10 to the 5? 100,000. Love it. Beautiful. Are all of you comfortable with how your calculators behave? You are not? Or you are? You are not. Okay, let's take a look. If you are not comfortable with your calculators, call me over. Let's take a look. That's the symbol you're using. Yeah. Yeah, that's the same as the TI. Sorry, I'm here. That's it. Yeah. No worries. Okay. Don't work ahead. I want to make sure all the bits and pieces are there. Carson, you figured it out with your calculator? Did you get these numbers? 625, 64, 13, and 100,000? Okay, cool. Fantastic. When you're ready, flip the page. Okay, let's have a conversation about negatives. Finicky little beasts. Okay. Before we do this, what does -2 mean? What is -2? Yeah. It's behind the 0. Okay. So it's 2 to the left of 0, 2 below 0. How do we get, what mathematical operations can we do to get to -2? I could do 0 minus 2. Nice and easy, relatively simple. Love it. How can I do it without adding or subtracting? You do it the other way, though. No, what's the other way? No, I want multiplication. You were so close. I don't want -2 times 1, though. I want... No, I want to start with 2 and make it negative. How do you do it, Benita? No, I want to start with 2 and make it negative. Mishwa. There you go. Except I'm going to swap the order on that. I'm going to write it as -1 times 2. This is what, and this is how I want you to think about it. This is how we're going to get to all of our negatives, and then BEDMAS is actually going to start to help us decipher how you handle negatives properly. So this is how I want you to think about this. This is really important. And we're going to use BEDMAS when dealing with what I'm about to show you. So when you got something like this, you got -2 cubed. The way this is written is you've got -1 times 2 cubed. So if this is -1 times 2 cubed, what do you do first? BEDMAS says brackets. Are there brackets? No. Are there exponents? Yeah, there are now. So that exponent has to happen before the -1 gets multiplied on. So then, if I have -2 cubed, no brackets, what's being repeatedly multiplied? 2, not -2. This, -2 to the power of 3, without brackets, the base is 2 because the exponent comes first. The exponent's a 3, and so the way we would write this then is it's going to be 2 times 2 times 2, and that -1 gets multiplied out front. The base is positive, the exponent is positive. That minus sign shows up as multiplication by -1 out front. Sorry?
I learned it as -2 times -2.
No, you didn't. Let me gaslight you here. No, you didn't. This is -2 times -2 times -2. Because what's going on here? This is the same as -1 times 2 inside those brackets there. And the 3 is on the other side. If you learned this being anything other than this last year, you were taught incorrectly. You were taught lies. Here, BEDMAS would say I do the multiplication inside those brackets first, giving me -2 to the power of 3. Inside those brackets, the negative becomes part of the base. So now the base here is going to be -2. The exponent is still 3. This one's going to be -2 times -2 times -2. You're right. I wasn't in your grade 8 class. I don't actually know what you were taught. So I'm not going to say that you weren't taught. I shouldn't say that you weren't taught it. But if you were taught that this and this are the same thing, you were misled. The confusing bit, though, is what's 2 times 2 times 2? And then you make it negative is going to be -8. Okay. What's -2 times -2 times -2? Also -8. So why am I making a big deal about this distinction? Benita. But if it results in the same thing, why does it matter? Daphne?
If there was an even number as an exponent, you would get a positive instead.
Because if I had an even number of exponents, I would get a different result here, which it happens to be exactly what my next two examples are. I've got negative and then 5 squared. What's the base here? If there are no brackets present, it's just 5. The exponent is a 2. So I like to write this as a -1 times 5 times 5. Sometimes you'll see it like this, -5 times 5. These are the same thing. But because that minus sign does not show up on everything, it's not included as part of the base. I prefer to write it like this. Sometimes you'll, put it this way. Sometimes, bless you, you'll see it like this. But this is how I want you to think about it. This would give you what result? -1 times 5 times 5 is -25. Here, what's going on? What's the base here, Benita? It's going to be -5 because that minus sign is included inside those brackets and the exponent is out. So my exponent is still 2. So now when I multiply this thing together in standard or in expanded or repeated multiplication form, it's going to be -5 times -5. And as Pavneet said before, when I have an even number of negatives, my result is going to be positive. So it only really matters when you've got even number exponents. But it's still an important distinction to make all the time. When the negative sign is outside the brackets, or if there is no brackets, it does not repeat. When the negative side is inside the bracket, it's part of the base and gets repeatedly multiplied. Okay. Oh, and remember, blank number of negatives multiplied is positive. The even number of negatives, as Pavneet here said, gives you a positive result. An odd number of negatives multiplied is a negative result. Okay. The similar principles apply when you have fractions. Last block, I tried to do this. They're like, decimals, half's 0.5, let's go. No, don't want to do that. Leave them as fractions. Your life will be easier. Repeatedly multiplying decimals is terrible. How do we repeatedly multiply a fraction? What does it mean to have a half and then in brackets outside a cubed? Mishwa, you almost put your hand up, but then I kept talking. What do we do? Yeah, fractions are just numbers too. The base is a half. The exponent tells you how many times to multiply a half. And I'm going to argue with you that multiplying fractions is easier than multiplying decimals. Because when you're multiplying fractions, what do? You just multiply across the top, multiply across the bottom. So this is going to be 1 times 1 times 1 here in the numerator, and 2 times 2 times 2 here in the denominator. 1 times 1 times 1 is 2 times, and then someone said it already. 2 times 2 times 2 is 8. I mean, if you wanted to take this to a decimal now, you could relatively easily, because a quarter is 0.25 and an eighth is a half of a quarter, so half of 0.25 or half of 25 is 12 and a half. So this would be 0.125. But if I asked you to do it the other way, what is 0.5 times 0.5 times 0.5? Some of you could say relatively easily that 5 times 5 is 25 times 5 is 125. Recognize that there's 3 decimal places there, and so do it this way. But I'm going to argue that multiplying 2 together 3 times is easier. Don't do this. Keep them as fractions as often as possible. Okay, 2/3 to the 4. This is going to get even grosser if you convert it to a decimal. Because if you had 2/3 is 0.6 repeating. How do you multiply an infinite repeating decimal longhand? Don't, is the short answer. You'd be there literally forever. And now you have to do it 4 times. That would suck. How do you multiply? If the first multiplication you'd have to take is 4 times, is infinite, how do you infinitely it just doesn't work. So leave it as a fraction and let's do. 2/3 to the power of 4 means, as was stated before, that fraction just gets repeated. The base is the fraction. 2/3 times 2/3 times 2/3 times 2/3. It's just going to be 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. Pavneet already said it. 2 times 2 times 2 times 2 is 16, not 8. Because 2 times 2 is 4, and then 4 times 2 is, and then 8 times 2 is 16. What I often see here is the sloppy, oh yeah, I got this. 2 times 2 times 2 times 2, 8. Because, because they'll do 2 plus 2 plus 2 plus 2. Multiplication and addition get confused when you're going quick. Don't. This could be a little bit trickier because 3 times 3 is 9, 9 times 3 is 27. You might not be able to do 27 times 3 quickly in your head. It is 81, but here's a quicker way to think about it. 3 times 3 is 9. See, exactly that. Thank you for demonstrating. 3 times 3 is, and then 9 times 9 is. That's how I would suggest shortcutting this. And then I don't know what 1681s is as a decimal. It doesn't matter what 1681s is. It's probably infinite. 1681s. Yeah, oh yeah. Here's what we'd have to come up with. 0.19753086419. It goes on forever. Repeats. Looks like that. Good luck doing that by hand. Leave it as a fraction. Multiply it out. Leave your result as a fraction. Bringing in the minus doesn't change anything. This thing is still going to be, and I'm going to use brackets now to help organize our thoughts, negative a third times negative a third times negative a third. And now there's a couple ways you can think about this minus sign. One of the ways is to say, well, a negative times a negative is a positive, and then multiply it by another negative is going to have to give us a negative final value. Deal with the minus sign on its own. And then just do the multiplication. 1 times 1 times 1 is?
1.
3 times 3 is? Times 3 is 27, yeah. Or you could do what I've told you to do before and say, okay, I'm going to bring that minus sign up into the numerator, not the denominator. Mathematically, it's the same, but it's bad convention. It's like saying Clifford the big red dog and Clifford the red big dog. Yeah, see, I got a bunch of gross faces. Because it means the same thing, right? Clifford the red big dog and Clifford the big red dog. But we don't say red big, we say big red. Because there is an understood order to the adjectives that we use. Adjectives are used to describe nouns. For those of you who it's been a while since you've sat in an English class. Even though they mean the same thing, there's a correct order, a better order. So this would become negative 1 over 3 times negative 1 over 3 times negative 1 over 3, which would give you negative 1 times negative 1 times negative 1 over 3 times 3 times 3, which would give you negative 1 over 27. The result is the same. Yes.
Why would it be negative 1 if it's multiplied 3 times? Because if it's negative 1 times negative 1, then 2 positive.
I think you just answered your question.
Yeah, I just answered that.
You just answered your own question, which I love it when that happens. As soon as you say it out loud, you're like, oh yeah. Happens to me all the time. Okay, so based on what we just did, I want you to flip the page. Crank out this page if you haven't already. I want every one of these, power base, exponent, expanded form, and standard form, whole page. I'll walk around and help where I can. If there's questions and clarifications that are needed, there's some tricky ones that I slid in here for you. And then some fun little demos. Yes. Yeah, I will slow down. Lose everything. Okay. Oh, you also walked in halfway through. Okay, I will slow down. I'm also going to get rid of this. I'll leave that up there for a second. Have you seen this stuff before though? This should everything yes or no? Okay, so it is all repeat. Do you want me to go through it again? Or because you've seen it before, do you recognize what's going on? I will, from now on, I will speak slow. Try. Okay. Oh, that mess.
So what's going on?
Bed. Max.
I think I'm just gonna ignore it so you can't say something.
Oh,
I don't trust it to be anything.
okay. This club always needs to have 5 chairs at it. So Namrush, if your desk has a chair at it, I'm just get one of these guys to move the chair at your desk to one of the other spaces here. I always want to have 5 desks on this club. Yes, Carson. And yes, do use a calculator for standard form. For your calculator? It's great. I can do that. Because there is no number to a value. You fill the rest of them, but not the real. If the box is grayed out, you can't put anything in. Yep. Beauty. Yep. Oh, did you? Sometimes I think these can be completed. It's not printing. That's your option. It is. Oh, sorry, it was on. Why does this? Usually, I like in hospital.
Yeah.
You said it already. Yeah. Okay, gotcha. Someone said something about them putting pictures on
There's an extra layer.
Yeah, exactly.
So to see if it doesn't come up with you a problem.
Right.
Okay, my thing, the pencil is not helping you. It's just sitting in your lap. Let me know if I can help you. Yes, Nicholas.
That is one of those where you put your answers.
You do the math, look for results. And now you can use the calculator for it.
Okay. Complete letter. Cool. The exponent is 3. So then this is going to be 6 multiplied 3 times. Standard form there, you're going to get your calculator out. 6 times 6 times 6 is 216. Love it. If I got a bunch of 2's multiplied together, the base is 2. The exponent is, because there's 5 of them multiplied together, which means that as a power, it'll be written as 2 to the 5th. And in standard form or evaluated form, that is going to be 32. Okay, the next one. You cannot evaluate this. You cannot put it in standard form because there is no number to multiply here. Instead, we're multiplying a bunch of fancy x's together. Yes, Kuntas? The base is a fancy x. The exponent is 4 because there's 4 of them. So in power form, it's going to be fancy x to the power of 4. Love it. And again, there's nothing to evaluate because there's no number there to calculate. Okay, cool. Next one. What is the base here? It is not 5. There is a negative 5 inside the brackets and a squared outside. So the exponent here is going to be a 2. So I'm going to have a negative 5 times a negative 5. But then that minus sign out front needs to get tacked on through the multiplication of a negative 1. So then in standard or evaluated form, this is going to be negative 25. What's the base here? It's 3. The exponent is 5. If we go to power form, there's a minus sign here. How do I include that minus sign in the power form? Negative 3 to the power of 5 with either no brackets or negative with a 3 inside to the power of 5. Either one of those two ways is how you could write that. This guy? Oh, we need a standard form. Standard form here is going to be negative 243. Negative 9 to the 3. That negative's inside, so that's going to be part of the base. We're going to have negative 9 times negative 9 times negative 9. You're going to punch that in your calculator, and you're going to get negative 729. This guy, the negative is included as part of the repeated multiplication, so it needs to be included as part of the base. There's 5 of them there still. So this one needs to be written as negative 3 with that minus sign in brackets to the power of 5. So that's going to be negative 243 again. This guy is going to be a base of 9, an exponent of 3. That minus sign gets tacked on as a multiplication by negative 1 in expanded form, and then this is going to give us negative 729. There's 3 zeros there, so how many times did I multiply the 10s together? 3 times. So 10 times 10 times 10, or 10 cubed. Base in the next one's 1 and 7. 1 times 1 times 1 times 1 times 1 times 1 times 1 is
1.
not 7. Good. 1/3 to the 5. The base is 1 over 3. The exponent is 5. And I'm multiplying a bunch of fractions together. So my result needs to be a fraction. I multiply a bunch of 1s across the top. 1 times 1 times 1 is 1 over. You need to be deliberate here. 1 over 243. This is not the same as 243. If I offered you 1/243 of a pizza or 243 pizzas, that is a fundamentally different number of pizzas. Not the same thing. This guy is going to be negative 3 over 7. That's exponents of 3. Negative 3 over 7 times negative 3 over 7 times negative 3 over 7 is going to be what? Negative 27 over 343. Include that minus sign as part of your numerator. If you need to multiply that together in your calculator, go ahead. But negative 3 times negative 3 is positive 9 times negative 3 is negative 27. You should be able to do that without a calculator. But the 7s, I don't expect you to know those cubes. But again, your final answer needs to be a fraction. This guy, y to the 6th, the base is? The exponent is 6. So y times y times y times y times y times y. Cool. What's this? Base is not negative 3 over 2. The base is just 3 over 2. There's only one minus sign there. The exponent is a 4. So when I write this out, it's going to be negative 3 over 2 to the power of 4. You could either put no brackets or you could put brackets like this. You've been gone this long without your stuff? Okay, well, welcome back. That took a long time. When I only got one negative, my final answer is going to be negative. 3 times 3 is 9 times 3 is 27 times 3. We've done this already, is 81 over 16. And then the last one. 1, 2, 3, 4, 5. The exponent here is 0. What does that even mean? Some of you said, yes, 12,345 times 0 is 0. It's not. Let's take a look at that. Yes, Pavni.
It means you multiply it by itself 0 times, so it just stays the same number.
Good guess, but you'd be incorrect. Let's go through it. Okay, so I'm going to show you what it looks like doing it this way. 2 cubed is what? What does that mean? 2 cubed. 2 times 2 times 2. 2 times 2 times 2 is? Okay, cool. 2 squared is? I'll take the whole path back over here. As repeated multiplication, it's 2 times 2. 2 to the 1 is 2. Okay, so let's look at how we got here. How do you get from 8 to 4? Using 2's. You divide. Yeah, divide it by 2. You can see here what happened. I had 3 2's multiplied together. If I divide these 3 2's by 2, it's going to cancel out with one of these because 2 divided by 2 is 1. So I'm going to have 2 times 2, which is 4. Make sense? And look what dividing by 2 did. What did it do to the exponent? Yeah, knocked it down one. Yeah. So, divide by 2 again. Divide by 2 again. The exponent drops from 2 to 1. 4 divided by 2 is 2. Again. 2 divided by 2 is? When I divide over here by 2, what do I get? 2 to the power of 0. So 2 to the power of 0 is 1. I totally arbitrarily picked the number 2 there. Could I have put any other number here? I could put 3 here. 3 would have been, 3 to the 3 would have been 3 times 3 times 3 is 27. And then 3 squared would have been 9. 3 to the 1 would have been 3. 3 to the 0 would still have been 1. It does not matter what your base is. Anything to the power of 0 based on this argument is 1. So that last, it does not, there is nothing to put here. It does not make sense to repeatedly multiply something no times. The box stays blank. And in the last one, in standard form, anything to the power of 0 is 1. Good toss. Okay. We could start more things, or I could save it till tomorrow. Okay, if you didn't finish the chart, your job is to finish the chart. If you did finish the chart, you may put your math away. Return my calculators, please. Get your devices back. My calculators need to come home.
I have the right. I just want to.
Turn my calculator. You guys. Okay, I need some calculators back. Whose phone is this? It's a pretty cool case. Not gonna lie, big fan. Yeah, Avengers sticker and everything. Yeah, that's really cool. Who's this? Excellent. Whose is this lovely blue thing? Sometimes it's you. Okay. Love it. Nice case. Very cool. Here you are. And then I've got two that had nothing in it, which I think were the two that I took. Love it. Boom and boom. Okay, so